Hello again and welcome to another GCSE computer science lesson. This video is going to be on Unit 5, Network Topologies. Alright then, so why do we use networks? Why are they so cool? Well, let me start off by pointing something out really important here. When we're talking about computer networks, we are not necessarily talking about the internet. I mean, the internet is a massive computer network, but you don't have to be connected to the internet to be part of a network. So in this example, we've got a network here, we've got some PCs, we've got a printer, we've got a server, they're all connected, but they're not necessarily connected to the internet. So just something to bear in mind when you're talking about this in the exam paper. Now, what's good about a network? Why do we use them? Well, we can share things very easily on the network, including hardware. So this printer is very easily shared amongst these 4 computers on the network. So this PC can easily send a file over to the printer without getting out of their chair. Isn't that great? You can use a computer, you can use a printer without getting out of your seat, except for when you actually have to pick up the document that you just printed off. But ignoring that fact, you don't have to get out of your seat at all. What else is good about a network? Well, this PC can communicate with this PC down here just by sending a little message using a piece of software. That's pretty cool. And you're probably thinking, I thought you needed an internet connection to use something like email. That's not true. You can have email servers, like for example this little server here. You can have an email server inside your organization's basement that will do a small internal email that doesn't need an internet connection. So there you go, myth dispelled for you. You don't have to have the internet to have emails. What else is good about a network? So we can communicate, we can share printers and things like that. What else is good about a network? Well, let's say this computer up here spontaneously catches fire and explodes. Well, all those files are backed up safely because this server has been doing a bunch of backups for us, which is pretty cool. What else is good about a network? Well, this is arguably good and bad. Teachers think it's a good thing, students think it's a bad thing. But as a teacher, I can spy on my students, which is pretty cool. So if they're doing things they shouldn't be doing, like playing video games or otherwise just prattling around not doing the work, I can see through the magic of computer networking what they've been up to. Alternatively to using networks, you could use standalone PCs. So these PCs aren't connected to each other in any kind of way. Why would anyone use this? Not really sure. You'd have to be really old-fashioned to not want to use a computer network, but I'll talk you through how this could possibly work. Let's say this PC up here wants to send a file to the printer. Well, they'd have to put it on a floppy disk or a USB drive, walk over to this computer, and then press print. So it's a bit tedious, this kind of network. It's not so bad with this example of 4 computers, but let's imagine you had a school of 1,000 students. You'd end up having a queue of about 1,000 students with USB drives at the ready, just queuing up to use that one computer that was connected to the printers. It's not a good idea. Why would anyone ever want to use this instead of a network? What advantages does not using a network have over using a network? Well, there's a few advantages. See this switch thing in the middle? That costs a lot of money. Now, off the top of my head, for one that's good enough for a school network, you're looking at least £1,000 for this switch. If we had this system, we wouldn't have to spend that £1,000. So it's cheaper in some ways. Not cheaper for the sense that we don't have to buy this switch and all the associated connections. It's cheap because we also don't have to pay somebody to look after this network. So no one has to manage this, so we're saving some money there too. What else is good about standalone machines? Let's see. Viruses. It's going to be pretty difficult to share viruses between these machines, whereas on a network, that virus is going to spread around there quite easily. But without the network, there's no network to spread around, so happy days. What else is there? There's one more thing. Let me think about it for a second. Yes, slowdowns, performance issues. In your networks at school or in an office or what have you, you might find it takes a little bit of time to log into your computer, especially if the network's busy. Well, if you don't have a network, then problem solved. There's no network to get slow. So, kind of solves that problem just by removing it altogether. The biggest advantage of not using networks is probably more to do with stability than anything else. So let's take this server in this example I've got here. Let's pretend that this server contains all of the usernames and passwords for students around the school. What happens if this blows up or catches fire? Well, these aren't going to do anything. You're not going to be able to log in. But in this system, we don't have such a concept. There is no server, so we don't have to worry about that problem because it just doesn't exist. Okay, so I'm just going to give you what I just said to you, but written down, so you can take your own notes if you like. It's important to establish that networks don't necessarily mean the internet. Networks are good because you can share hardware, you can share files and other stuff. Networks are good because you can spy on your users. And networks are also good because you can communicate between machines using things like email. Why shouldn't you use networks? What's bad about networks? Well, networks are expensive, they require maintenance, you can spread malware, they can be slow, your computers can slow down if the network's busy. And also, if your whole network can fail if a key point fails. So going back to my diagram, if that switch were to break, everything else would stop working. If this server were to catch fire, everything else in this network would stop working. Okay, next we're going to talk about network topologies. The first one we need to know about is called a personal area network. So that's what PAN stands for, personal area network. And a personal area network normally includes just two devices connected together over a few meters. The best example I can come up with is perhaps a smartphone connected up to some Bluetooth headphones. You might be noticing, why have we got a wire here connecting these two devices? That's not a wire, that just demonstrates that there's a connection. So even though it looks like a wire, it just means a connection. Likewise for these diagrams, these aren't necessarily wires, they're just demonstrating a connection between devices. Like these could be wireless signals connecting all these devices up together. Okay, and this is just PAN written down on the slide for you to take notes. So a PAN is two devices and it's normally over a few meters. Okay, next is a LAN topology. So it's the example I just used with you. So an example of a LAN is maybe a classroom. Another example could be an office. And the most common example is your house or your home. So having like your family laptop, your family printer, your mum's computer, your smartphones, all connected up to the home hub or router or whatever you call it these days. So like your house could be the simplest version of a LAN. And this is just what I talked about written down. So a LAN is a small geographic location. Examples include a home or an office or a classroom. Okay, moving on to something called WAN. Now this gets a little bit tricky, so do be patient with me and stick with it. A WAN stands for a wide area network. It is two LANs or more connected to each other. So we take one LAN, we take another LAN, and we take a big old wire and we connect the two of them together. Or more, it could be three, it could be four LANs, but in this example we're just using two. So it is a really, really big cable. Now you're probably thinking, what is the point? What makes this a WAN and not a LAN? Well, a WAN is made of multiple LANs, and this cable could be separated by two buildings. So this could be one building, this could be a second building, this could be one office, this could be another office, this could be a house on one street, this could be a house down the road, for example. I mean, these are pretty rubbish analogies, but I'll give you a better example. An example of, say, a business park. Not that kind of business park, not where businessmen go to play on the swings and slides and things. This kind of business park. So let's say we've got office or building A is the same company as this one. Let's say we've got one company, they own two buildings and they want to connect them together. So this is an example of a WAN. And when we say a big old wire, we don't mean just sort of sticking a big Ethernet cable outside of your office window and then getting somebody to hold it in the air saying, oh, watch that cable, don't trip. We mean actually getting some proper engineers in to dig up the tarmac and actually bury these things underground. Costs a lot of money. You've got to pay people to dig up the road. You've got to pay the council to get permission to do so. But so just to clarify, when we talk about WAN with that big old cable, it's all done professionally. Companies get permission to stick these things under the ground. You're probably thinking, what is the point in a WAN? You know, that sticking that big old cable under the tarmac is going to cost a lot of money. Why not just, connect to each other through the power of the internet? Well, you raise a good point. A lot of companies do this now. They just connect through the internet. So you've got to wonder, why does anybody still do this thing underground? Why do people spend all this money? There's a couple of reasons, and you don't need to be aware of this for the exam, but just in case you're interested, companies might decide to go for a massive WAN cable for reliability. So just in case something goes on with the internet, they've got this backup connection. But it's also about speed. This cable is going to be so much faster than doing things through the internet. So reliability and speed is the main reason why people still have big WAN cables. And this is just what I talked about, but written down on a slide for you. So a WAN is multiple LANs. They cover a large geographic location. And they're normally combined of multiple offices or buildings connected together. Usually they're all part of the same organization.